Welcome to The Explainer. Today, we're ripping the lid off the most powerful consumer graphics card on the planet, NVIDIA's GeForce RTX 5090. We're going to dig into the silicon, the cooling, and of course, the raw gaming numbers to see what really makes this absolute beast tick. You know, this right here is the fundamental challenge for every single new generation of GPUs. And it's the core engineering problem the RTX 5090 was basically designed from the ground up to solve. It's this incredibly delicate balancing act, right? Pushing performance to the absolute limit while trying to figure out how to keep the whole thing from, well, melting. Okay, so let's get right into it and start by looking at the completely new architecture that's powering this card. And listen, this isn't just some minor refresh. We're talking about a fundamental change in how the GPU actually thinks. So it's named in honor of the mathematician David H. Blackwell, and this new architecture is a total ground-up redesign. The big goals here were all about optimizing for new neural workloads. You know, think way more complex and realistic AI characters in your games. And also a relentless focus on energy efficiency, which is absolutely critical given how much power this card is drawing. Now, what's really interesting here is the change they made to the heart of the GPU, the streaming multiprocessor, or the SM. So if you look at the Blackwell SM, you'll see NVIDIA has completely unified the integer and the floating point cores. Now, in simple terms, what that means is for a lot of the common in-game calculations, things like physics or AI processing, the GPU can get twice as much work done in the exact same amount of time compared to the last generation. That's a huge deal. Another massive leap forward is the move to GDDR7 memory. This is actually a first for any consumer GPU. It uses this way more efficient signaling technology called PAM3 to just push data rates higher while at the same time making it more energy efficient. And that upgrade is absolutely critical for feeding this beastly new core. In this chart, well, it just brilliantly illustrates the real-world impact. You can see that big jump in the data rate, but also that significant improvement in energy efficiency. All said and done, this one upgrade delivers a staggering 78% improvement in total memory bandwidth over the already incredibly fast RTX 4090. And if you want to put that into raw numbers, we are jumping from roughly 1 terabyte per second to nearly 1.8. That is an absolute fire hose of data, and it's so crucial for keeping those powerful new Blackwell cores fed with all the textures and geometry they need, especially when you're pushing crazy high resolutions like 4K. So, the big question: how does all this new architecture actually translate into gaming performance? I mean, at the end of the day, all the theory in the world doesn't matter if it doesn't actually deliver more frames per second. Okay, in standard 4K gaming, and this is without ray tracing on, independent benchmarks from folks like Gamers Nexus show the 5090 is anywhere from 20 to 50% faster than the 4090. Now, that's a pretty wide range, and it really just depends heavily on the specific game and how well it's able to use that new architecture. But then, when you flip on demanding ray tracing at 4K, that lead holds really strong. The performance uplift is actually more consistent here, with benchmarks showing a really solid 27 to 35% gain over the 4090. That's a significant, really tangible improvement in the absolute most graphically intense situations. However, you've probably seen NVIDIA's own marketing, right? And it paints an even more dramatic picture of performance, often showing these performance bars that look like they're twice as high as the last generation. But as reviewers over at Gamers Nexus were really quick to point out, this comparison isn't exactly, well, it's not apples to apples. See, the marketing chart compares the 40 series using standard frame generation, that's the AI tech that inserts extra frames, against the 50 series using a brand new multi-frame generation, which creates even more AI frames. It's a valid technology, sure, but it doesn't really represent the raw head-to-head hardware uplift. All of that performance creates one heck of an engineering problem: heat. And that brings us to the card's totally radical new cooling solution, which honestly is almost as impressive as the silicon itself. So let's talk about the crucial number here. The card has a total graphics power of 575 watts. I mean, that is a huge jump from the 4090's 450 watts. And trying to dissipate that much heat from a consumer product, that is a monumental task. So, to handle this, NVIDIA developed a completely new Founders Edition cooler. It's got a dual flow-through fan design, and get this, for the first time ever on a Founders card, they're using a liquid metal thermal interface on the GPU die itself, all protected by a special triple-walled gasket. And somehow, incredibly, they fit this all into a sleek 2-slot design. This dual flow-through design is, well, it's pretty brilliant actually. It basically sandwiches the main circuit board between two separate heat sinks and fans. So it pulls cool air in, shoves it through the fins, and then exhausts all that hot air up and away. This is super important because it helps prevent the GPU from just sucking its own hot exhaust back in and cooking itself. And hey, the results really speak for themselves. In stress tests, the GPU core itself stays at a genuinely impressive 72 degrees Celsius. The new GDDR7 memory, though, it does run on the warmer side, hitting around 89 to 90 degrees. So that's definitely something to be mindful of if you have a case with restricted airflow. Okay, so let's pull back for a second and look at what this all adds up to. When you put all these pieces together, what does this new flagship graphics card really represent? When you look at it side by side, the 5090 is a true generational leap. We're talking more VRAM, a revolutionary new memory type, way more bandwidth, and a totally new architecture. But it also represents a pretty big leap in power consumption and, of course, in price. That launch MSRP of $2,000, that's a pretty significant $400 increase over its predecessor. This sets a new and very, very high bar for what a flagship consumer graphics card costs right out of the gate. Which, of course, leaves us with the ultimate question for any hardware enthusiast who's eyeing the bleeding edge of technology. The RTX 5090 is, without a doubt, the new king of performance. But is its price a necessary cost for pushing the boundaries of gaming and AI? Or is it a luxury that pushes the very definition of consumer hardware to its absolute limit?